Using the law of sines, we need to show that in a triangle ABC, the following equation is true. So let us begin. We'll first specify the law of sines. So if we have a triangle ABC where the letter A, B, and C in lowercase represents the sides opposite to angle A, angle B, and angle C respectively, then the law of sines states that the ratio of side A to that of sine of the angle opposite to it equals the ratio of side B to that of sine of the angle opposite to it. That is also equals to the third side C to that of sine of the angle opposite to it. So this is the law of sines. Now in order to solve this problem, we will use this law of sine and we will consider that the three ratios be equals to a common constant, and we are going to call it 1 over lambda. Now we're doing so, now we can specify the value of sine A. So sine A will be equals to lambda times A. Then sine B can be represented as lambda times B, and sine C will be equals to lambda times C. So let's begin from the left hand side of a given expression. So here we have in the numerator square root of sine A. So if we replace it with value lambda times A, so we're going to get square root of lambda multiplied to A, minus we have square root of sine B, so that will be square root of lambda times B. Then in a denominator we have square root of lambda times A plus square root of lambda times B. Now we can factor out square root of lambda from both the numerator and the denominator, and we're left with square root of A minus square root of B whole divided by square root of A plus square root of B. Now what we can do, we can rationalize the denominator. All we have to do is multiply the numerator and the denominator with the conjugate of the denominator, which is square root of A minus square root of B. That means we are going to get square root of A minus square root of B whole square in the numerator, and in the denominator we have square root of A plus square root of B multiplied to square root of A minus square root of B. Right. So if we expand the numerator, we're going to get square root of A whole squared plus square root of B whole squared minus 2 times square root of A multiplied to square root of B whole divided by, so square root of A plus square root of B multiplied to square root of A minus square root of B. So that's simply square root of A whole squared minus square root of B whole squared. So further simplification is going to give us A plus B minus 2 times square root of AB whole divided by A minus B. So this is the expression on the right hand side. Hence we have successfully showed that the left hand side of the expression equals the right hand side, hence proved.